Alright, Math 8 students, we are starting lesson 12.2, the converse of the Pythagorean theorem. And so we started a little bit of this in class today, so we're continuing this looking at our explore activities and our examples and completing these your turn questions. Let's take a look at our essential question here. How can you test the converse of the Pythagorean theorem and use it to solve problems? Well, remember the Pythagorean theorem is that a squared plus b squared equals c squared. So when we use it to test the converse of the Pythagorean theorem, we're going to remember that the Pythagorean theorem states that if a triangle is a right triangle, that's important, then a squared plus b squared equals c squared. Well, a squared is one leg, b squared is the length of another leg squared, and c squared is the hypotenuse squared. Okay? And this works for right triangles only. So the converse of the Pythagorean theorem states that if a squared plus b squared equals c squared, then the triangle is a right triangle, right? So what we're doing with this is we're determining if, when given side lengths, triangles are right triangles. Because if the statement is not true, then it is not a right triangle. And we had taken this a little bit further with the work that we did in class, and we were able to even classify them as acute or obtuse triangles based on what we determined from the converse of the Pythagorean theorem. So what we're going to do is we're going to go ahead and decide whether the converse of the Pythagorean theorem is true. So we're going to verify that the following sets of lengths make the equation a squared plus b squared equals c squared true, and record our results in the table. So what I'm going to be doing is I'm going to be plugging each of these into the Pythagorean theorem, make sure that a squared plus b squared does equal c squared, and then if it does, if it is true, it is a right triangle. So I'm going to go ahead, I'm actually going to move this over to the side just a little bit so I can do some work over here on the side, just to check. So I'm going to get my a squared, which is in this case is 3 squared, plus 4 squared equals 5 squared. So that's what we're trying to determine. Is that true? So 3 squared is 9 plus 16 equals 25. 9 plus 16 is 25, and that does equal 25. So yes, it's true, which means it is a right triangle. And then we're going to do that same thing for this next one. 5 squared plus 12 squared equals 13 squared. Is it true? 5 squared is 25, plus 12 squared is 144, equals 13 squared, which is 169. 25 plus 144 is 169. So that is true. So this is true. 169 does equal 169, and so yes, it is a right triangle. So we're just going to continue down this here, and I'm going to have notes kind of all over the paper here, just because that's where I've got space. So I'm checking 7 squared plus 24 squared, and see if it equals 25 squared. So 7 squared is 7 times 7, which is 49. Whoops. Need my pen. 49, and 24 squared is 576, and then 25 squared is 625. So then I got to add these up. 476 plus 49, and it equals 625. So 625 does equal 625. This statement is true, and yes. Okay, we got 2 more here that we're going to work through. 8 squared plus 15 squared equals maybe 17 squared. See if it's true. 8 squared is 8 times 8. 8 times 8 is 64. Plus 15 squared, which is 15 times 15, which is 225. And does it equal 17 squared? 17 times 17, 289. So 64 plus 225 equals 289. So these are equal. So those are equal. Just kind of circle my answers here so we've got a little bit of organization. So yes, this is true. And yes, it is a right triangle. And then our last one, we're going to find some space here. 20 squared plus 21 squared equals 29 squared. So 21 squared, no, 20 squared first. 20 times 20 is 400, plus 21 squared, which is 21 times 21, 441. Does it equal 29 squared? 29 times 29, which is 841. So then 400 plus 441 equals 841. So this is also true. And that means yes, it is a right triangle. Okay, let's go ahead and get back over here and take a look at what it wants us to do with B. For each set of lengths at the table, in the table, cut strips of grid paper with a width of 1 square and lengths that correspond to the values A, B, and C. So that's what they did here. That's what they wanted us to do. That's going to take some time. So you are welcome to do that, but we're going to go ahead and just imagine that we did that. For each set of lengths, use the strips of grid paper to try and form a right triangle. An example using the first set of lengths is shown. Record your finding as the table. So they used the lengths of 3, 4, and 5, which is these values right here for A, B, and C. So 3, 4, and 5. Were they able to make a right triangle? Yes, they were, by putting all those side lengths together. So we do know that this is true, and we do know that they will make a triangle. So all of these, when cut into strips of paper, will also all be able to make right triangles. So let's go ahead and reflect. And based on your observations, explain whether you think the converse of the Pythagorean theorem is true. Do you? Well, yes. At each of the side lengths, if each of the side lengths satisfies the Pythagorean theorem, a squared plus b squared equals c squared, and forms a right triangle, then they should conclude that the converse is true, right? So, yes. Because each side length satisfies, I think I spelled that right, satisfies a squared plus b squared equals c squared, making a right triangle. I'm going to run out of room. Meaning the converse is true. So yes, since each side length satisfies a squared plus b squared equals c squared, which is the Pythagorean theorem, and makes a right triangle, this means that the converse is true. All right, so that's it for the first explore activity. Let's go ahead and see what we've got on our next. All right, so we're going to identifying a right triangle. So this is kind of similar to what we did in class today with our activities. We are going to be given inches, or measurements, given side lengths, and we are going to plug them into our Pythagorean theorem and determine if it's a right triangle. If the statement is true, they are a right triangle, right? If a squared plus b squared does in fact equal c squared, it is a right triangle. So let's walk through these steps here real quick. We have given side lengths, and remember, right triangle. The longest one will always be C. That's your hypotenuse. So the biggest length will always be C. A and B are interchangeable. So you've got 9, 40, and 41. And you're going to plug those into A squared, B squared, and C squared. So 9 squared plus 40 squared plus 41 squared. 9 times 9 is 81. 40 times 40 is 1600. And 41 times 41 is 1681. When you add these two together, you get 1681 equals 1681. So a squared plus b squared does in fact equal c squared. So since it is true, it is, and satisfies the Pythagorean theorem, the converse of the Pythagorean theorem, it is a right triangle. And then they went ahead and gave you another example here where they gave you side lengths, and you had to plug those in. Okay, so you've got 8 meters, 10 meters, 12 meters, and we're going to plug each of these into the Pythagorean theorem. Remember, the largest one always needs to be C. Okay, so you got 8 squared plus 10 squared maybe equals 12 squared. 8 times 8 is 64. 10 times 10 is 100. 12 times 12 is 144. We're going to add these up. 64 plus 100 is 164. In this case, it is not true. A squared plus B squared equals 164, but C squared equals 144. So since these two are not equal, since it does not satisfy A squared plus B squared equals C squared, it is not a right triangle. And we also know that from our activities in class, since C squared is smaller than A squared plus B squared, it's also an acute triangle. We do know that. So just as some additional information there, we know that it's an acute triangle. So we're going to go ahead and take a look at the Your Turn questions. Bring this up so we have some room down below. And so we've got 3 side lengths. We're going to plug it into our Pythagorean theorem. So 14 squared plus 23 squared equals maybe 25 squared. So 14 squared is 14 times 14, which is 196, plus 23 squared, 23 times 23, is 529, maybe equals 25 squared, and 25 times 25 is 625. So we need to add our A squared and B squared up. 196 plus 529, and we get 725. 725 is not equal to 625, so it is not a right triangle. What type of triangle is it? What do we know from our activity in class today? That this is actually, since C squared is smaller, that would be an acute triangle. Just extending the math there a little bit. Okay, let's take a look at number 3. We've got 16 squared plus 30 squared maybe equals 34 squared. So 16 squared is 16 times 16, which is 256, plus 30 squared, which is 30 times 30, which is 900. And then we're going to see if that is equal to 34 squared, which is 34 times 34, 1156, 1156. We're going to add these two together, 900 plus 256, and we get 1156, which is equal to 1156. So A squared plus B squared is equal to C squared. So this is a right triangle. We're going to go ahead and check these last two here on Your Turn. And we've got 27 squared plus 36 squared maybe equals 45 squared. So 27 squared, 27 times 27 is 729, plus 36 squared, which is 36 times 36, 1296. And does it equal 45 squared? 45 times 45, which is 2025. So we're going to add these two together. 729 plus 1296, and we get 2025, which is equal to 2025. So A squared plus B squared is equal to C squared. So this is a right triangle. And then our last one here, I should just label this 2, 3, 4. The last one here we're looking at 11 squared plus 18 squared equals maybe 21 squared. So 11 squared, 11 times 11 is 121, plus 18 squared, which is 18 times 18, 324, maybe equals 21 squared, 21 times 21, which is 441. Going to add these two together. So 324 plus 121 equals 445, which is not equal to 441. So this means that this is not a right triangle. Because they are not equal, it is not a right triangle. Since this is smaller, this would also be an acute angle, or acute triangle. So not right, not a right triangle. Okay, so we're going to go ahead and see what they have for us next in our example 2. Let's go ahead and enlarge this. So we are using the converse of the Pythagorean theorem, and it's telling us we can use the converse of the Pythagorean theorem to solve real-world problems. Sweet. So let's do it. So in example 2, we are looking at Katya, who is buying edging for a triangular flower garden she plans to build in her backyard. If the lengths of the 3 pieces of edging that she purchases are 13 feet, 10 feet, and 7 feet, will the flower garden be in the shape of a right triangle? Okay, so we've got 3 lengths here. The important thing you need to remember is that your biggest one always needs to be C. Okay, so that needs to be your C squared. And then these ones will be your A and B. Okay, so we're going to plug those values in to Pythagorean theorem. And we've got 7 squared from here plus 10 squared right here equals 13 squared, our longest one. Then we're going to solve those. 7 times 7 is 49, 10 times 10 is 100, and 13 times 13 is 169. So when we add these two together, we get 149 and 169. These are not equal, so these side lengths will not make a right triangle. They will not be in the shape of a right triangle. So same thing, just applying it to real-world situations. Okay, so let's take a look at what they have us doing in your turn, where we are practicing these ideas. Go ahead and just slide this down so I've got some work space down below to work. Number 6, a blueprint for a new triangular playground shows that the sides measure 480, 140, and 500. Is the playground in the shape of a right triangle? And explain. So there's 2 parts to this. Yes or no, right triangle, and why. How we know. So first thing, note that your longest length here is 500, so that needs to be your hypotenuse and needs to be C in your Pythagorean theorem. Then we're going to plug this in here to our A squared plus B squared equals C squared, maybe, right? So our short one, I like to make our smallest number A. So I'm going to do 140 squared plus 480 squared maybe equals 500 squared. Let me just scroll down a little bit. And so 140 squared, 140 times 140 is 19,600 plus 480 squared, which is 480 times 480, which is another giant number, 230,400. And we want to know, does that equal 500 squared? 500 times 500. That's a giant playground, which equals 250,000. Okay, so we need to add these two up, 19,600 plus 230,400, and see what they equal. And I'm going to plug this into a calculator. These are big numbers. You are welcome to do this longhand. You are also welcome to use a calculator. And so these equal 250,000, which is equal to 250,000. So this does form a right triangle. So yes. And our explanation can simply be our work here. So we could write 140 squared plus 480 squared equals 500 squared, and then I will just go ahead and put the answer down here where I've got 250,000 equals 250,000, which proves that it's a right triangle. Okay, so moving on to 7, and I'm going to slide this down a little bit. A triangular piece of glass has sides that measure 18 inches, 19 inches, and 25 inches. Is a piece of glass in the shape of a right triangle, and explain. Okay, so just like the one before, we're plugging these into our Pythagorean theorem. Our longest one needs to be C. So we've got 18 squared plus 19 squared maybe equals 25 squared. So 18 squared, 18 times 18 is 324. Plus 19 squared, 19 times 19, 361. Does it equal 25 squared? 25 times 25, 625. So I've got to add these two up here. 324 plus 361 equals, let's scroll down a little bit. Okay, find my pen again. Equals 685, which is not equal to 625. Okay, so no, this is not a right triangle, and I can prove it because 18 squared plus 19 squared is not equal to 25 squared, because that would be 685 is not equal to 625. So that's my proof there. And then the last one we've got, applying it to a real world situation, is number 8. A corner of a fenced yard forms a right angle. Okay, so it forms a right angle. Can you place a 12-foot long board across the corner to form a right angle for which the leg lengths are whole numbers? So this would be, so we've got, what we have here is we have been given the corner of a fenced yard. It forms a right angle. So that's what it's telling us. We have the corner of a fenced yard that forms a right angle. And it wants to know if we can place a 12-foot long board across the corners right here. That would be 12 feet. Across the corners to form a right triangle for which the leg lengths are whole numbers. So it wants to know if a squared and b squared would be whole numbers if c squared, or the side length of c, is 12. So here is what we need to do. We need to determine if there is if there is numbers, two whole numbers that we can square that add up to be 12 squared, right? So whole number pairs. So this is a little bit of kind of guess and check. So we've got 12 squared, which is 144. And we're trying to find whole number pairs that add up to 144. So we can just start where, let's say, 2 squared plus 3 squared. This would be 4 plus 9. That's way too small. That's not going to work. So let's go back. Let's try something bigger. Let's try 5 squared and 9 squared. 5 squared would be 25. 9 squared, 9 times 9 would be 81. Oh, we're getting closer. 25 plus 81 is what? 81 plus 25 is 106. So we're getting a little closer, but still not at 144. Let's try, oops. Well, we did 5 and 9. Should we try 8 and 9? 8 squared plus 9 squared. So let's do 8 squared. 8 times 8 is 64, right? Plus 9 times 9 is 81. So 64 plus 81 equals 145. Okay. Which is not 144. And so if we went lower, if we went 7 squared on this side, it'd be too small. If we went 10 squared, right, if we went up 1 and down 1, that would be too big because that'd be 49 plus 100. That's too big. So if we went 8 and 8, that's going to be 64 plus 64, which will be too small. So this is the closest we can get here. But we can't get 144 without making one of these a decimal value. So there is no whole number values that will make 144. So you're not going to be able to form a right triangle with a hypotenuse of 12 if you want the legs to be whole number values. That's a little confusing, but that was a guess and check. So no, because there's no pairs of whole number values, of whole numbers whose squares add up to 12 squared. Oops, running out of room here. Okay. So that is the last of your turn. The next thing that we'll be looking at will be the guided practice, which of course all of these videos are optional viewing. If you have questions as we go through this, please make sure you're writing your questions down so we can talk about them, so we can go over them in class. Asking questions is important to understanding, so please make sure you're doing that. If you still want to watch a few more examples or get help as you walk through a few more questions, the guided practice will be posted after this.